Okay. So, so cube, roll up and cube. Okay. So, and both are used for what? To calculate subtotals and grand total. So, in the beginning, we written query like this. Okay. Then this, what this calculates? This calculates only department-wise total salary. If you say group by department number, means it calculates only department-wise total salary. But I want department-wise job-wise. Okay, na? Department, within the department, job-wise. So if you want, then you have to say group by department number, comma, job. Now department number job combination becomes group. Okay, na? So this combination becomes group. How many groups are created depends on how many combinations are there. 10th department clerk is one combination. 10th department manager is one combination. 20th clerk, 20th manager, 20th analyst, 30th clerk, 30th manager, 30th salesman. So how many combinations, how many groups are created depends on how many combinations. So there are 9 combinations. Then how many groups are created? 9 groups. And for each group it calculates what? Some salary. Okay, na? Then for each group it calculates some salary. Now as total salary. Okay, then so this calculates department wise, job wise. But it's not sorted. I want to sort. Then order by department number ascending. So job ascending. First department wise ascending. Within department job wise ascending. So first it is showing 10. 10th clerk, one combination. 10th manager, one combination. 10th president, one combination. And for each combination, it is calculating the total salary. 20th analyst. There are 2 employees belongs to 20th analyst. So the total salary paid to the 20th analyst is 6,300. There are 2 employees. The total salary paid to the 2 employees is 6,300. There are 4 salesmen, 30th salesman. How many employees are there? 30th salesman, 4. And the total salary paid to that 4 employees is 6,440. Understood that? Okay. So this is the actual output. Understood, na? Then. But in this output, I want to show the subtotals and grand total. To show the subtotals and grand total, use roll up or cube. So first, I use roll up. I'm using roll up. So if I use roll up, then what is the difference without roll up with roll up? So with roll up, it will show subtotals and grand total. Let me run this. Now what is 32,485 is grand total. And this is department subtotal. This is 20th department subtotal. This is 30th department subtotal. And for each department, it is showing the subtotals and also showing the grand total. So it's showing the subtotals for each group. 10th department is one group, 20th is one group, 30th is one group. For each group, it is showing the subtotals and also showing the grand total. So if I use cube, then then it is showing what? Grand total. Subtotals, what? Department wise subtotals and also job wise. It will show both department wise plus job wise. Okay. If you want only department wise, roll up. If you want both department wise, job wise, then cube. Okay. Then. So Now, okay, na? Understood? But here, okay, fine. Okay, na? So you're showing something 32,485. Because you return query, you understand what is 32,485. You know that this is grand total. You know this is what analyst subtotal. You know this 10th department subtotal 9620. Because you return query, you understand this. If end user will see that, will he understand what is 32,485? Huh? No. Then here will he understand what is 6,000, analyst 6,300, 10th department 9,620. Because for end users, everything should be mentioned. Then only they'll understand. Okay, na? Not only showing the values is important. What that value represents, that is also important for end user. Okay, then. So everything should be mentioned. Then they will understand. In this output, I want to show this is grand total, this is job subtotal, this is department subtotal. I want to show like that. So that end user will understand. Okay, na? What do you want to show? I want to show this is grand total, this is job subtotal, this is department subtotal. I want to show like that. Then, so SQL Server is provided a function called what's that? Grouping ID. SQL Server provided a function called grouping ID. And what for this grouping ID? Okay, then grouping ID. So this function accepts group by columns. Okay. This function accepts group by columns and returns subtotal belongs to which group by column. Okay. So this function accepts group by columns and returns subtotal belongs to which group by column. Okay, now let's see what grouping ID. Grouping ID. What it takes? See that group by columns. In our example, what are the group by columns? Department number, comma, job. So this grouping ID also takes group by columns. And what it returns? This returns what's that? Grouping ID function returns 1, 2, 3. This function returns 1, 2, 3. Return subtotal belongs to which group by column. Grouping ID returns 1 means the subtotal belongs to first group by column. Belongs to what? First group by column. First column of the group by. That is what? What that is? Department number. Grouping ID returns 2. Then subtotal belongs to second group by column. That is job. And next grouping ID returns 3. Then subtotal belongs to 3 means grand total. That's it. So using this function, we can find out whether it is subtotal is department subtotal, job subtotal, grand total. We can find out. Understood? Then now, now, now let's come to this query. Okay, then let's come to this query. Okay, now let's come to this query. This one. So here I want to show grouping ID value also. In this output, I want to show the grouping ID value. Then in this output bars, I want to show grouping ID value. Then where you have to write grouping ID? In the output, if you want to see something in the output, where you have to write? You want to see something in the output bars. If you want to see something in the output, where you have to call? You have to call it in select. Okay, na? Understood or not? You have to call it in what, sir? Select. Then comma. Then what do you want? Grouping ID. So what it takes? Grouping ID function takes group by columns. What are the group by columns? Department number and job. As once again, just see this as what? Subtotals. What is grouping ID function returns? What is this is grand total. Grouping ID function returns what? 3. If it is grand total, returns what? 3. And what this is? Job subtotal. For job subtotal, grouping ID function returns what? 2. And for this also 2, 2, 2, 2. And this is what? Department subtotal. For department subtotal, grouping ID function returns what? 1. Okay, na? Then returns 1. So let's run this query. See that 3. 3 means grand total. 2 means subtotal. 1 means department subtotal. 2 means job subtotal. Yes or no? Understood or not? Then. So actually what I said, why you are showing this? Because end users, they don't understand this 32,485 is what? What is 6,300? They don't understand. That's why we are using what's that? Grouping ID. And grouping ID returns what's that? 3, 2, 1. Is end user will understand 3 means grand total, 2 means job subtotal, 1 means department subtotal. Will he understand? No. Because he doesn't know what is 3, 2, 1. Yes. Anything should be, you're showing code, but don't show the code. Because users, they don't understand the codes. They understand only text. Okay, na? Then instead of showing 3, 2, 1, I want to show 3 means I want to show grand total. In place of 2, I want to show job subtotal. Here, if it is 1, I want to show department subtotal. I want to show like that. Then what? How to show that? Grouping ID returns 1, 2, 3 bars, but I don't want to show 1, 2, 3. Instead of showing 1, 2, 3, I want to show department subtotal, job subtotal, grand total, like that. Then if grouping ID equals to 1, show department subtotal. If grouping ID equals to 2, show then job subtotal. Grouping ID equal to 3, then grand total. Then tell me what we have to use. Always remember, like try to see if this equal to 1, if it is equal to this, if this condition true, this, if this condition true, this, if this condition true, this, then you have to use case statement. What we have to use? We have to use what's that? Case statement. If this condition true, return this value. If this condition true, return this value. If this condition true, return this value. Then you have to use case statement. Case statement. Okay. Then let's see. Let's come to what? Case statement. Case. Then what is this is? When what's it? Follow the syntax of case statement. When 1, then what? What is the meaning? If you write like this, grouping ID equals to 1. If grouping ID equals to 1, then what? Department subtotal. Next one. When 2, then what? Job subtotal. When 3, then what? Grand total. Every case statement should end with what? End as subtotal. So run this query. If grouping ID return value is 1, so we are showing department subtotal. Grouping ID return value 2, job subtotal. Grouping ID return value 3, grand total. That's all. Now, if you show like this, then users will understand. Yes. So, okay. That's all. Example, this one. Okay, then. So what is this is what grouping ID. First, what is grouping ID? Okay, na? What is grouping ID? Grouping ID function returns the subtotal belongs to which group by column. But what is grouping ID returns 1, 2, 3. But I don't want to show 1, 2, 3. I want to show department subtotal, job subtotal. That's why I'm using what's the case statement. That's it. Okay, then. na? That's it. With this, group by topic is completed. Okay. So in this topic, what you learned? In this topic, what you learned? What is the importance of what group by? Okay. Then plus we have seen where versus what's the having clause. Next one, roll up and what's the cube. Roll up and cube. Next one, grouping ID function. That's it. That's all. Okay. Okay then. Now, so what the next topic is? The next topic is integrity constraints. Okay. Okay, na? Integrity constraints. Then. So, up to now, you learned some what basic operations on database. You learned how to create tables, how to store what's data. Next, how to what update the data, how to delete the data, how to retrieve the data, how to retrieve. Okay, then at the time of displaying, retrieving, you know how to filter, how to sort, how to group. Okay, then you learn some operations on database. Now what we are going to see, we are going to see how to validate the data. We are going to see what's that? How to validate the data. So before storing the data needs to be validated. Okay, na? Before storing the data needs to be validated. Because the user may enter valid data or maybe he enters what invalid data. If user is trying to insert invalid data, we should not accept the data. We should not store the data in database. You have to say user that boss, your data is what? Incorrect, wrong. Understood or not? Yes. Because like for example, this is the table. This is the table, and in this table, suppose you inserted some data like this, name A, salary 5,000 like this. Next, so user is trying to insert data like this. ID is 100, name is blank, minus 2,000. He entering like this. But if he enters like this, then this data should be accepted or should not be accepted. This should not be accepted. So because this 100 is already given to this ID 100. This ID 100 is already given to one employee. The same ID should not be given to another employee. And the name should not be what? Blank. Person is there, name must be there. Name cannot be blank. Salary should not be what? Negative. Salary must be always positive. Sal should not be negative. Salary must be always positive. So if user is trying to insert this data, we should not accept this data. We should reject the data. Yes or no? Then how this can be done? This can be done with the help of what's our integrity constraints. Okay, na? So before you store the data needs to be validated. For validating the data, SQL server is provided some facilities. They are called integrity constraints. Okay, na? So like what the purpose is validating to prevent users from entering what invalid data. So why it is named as integrity constraints? Okay, na? Why this named as constraints means what's the rules? Constraints means what's the rules? And they are the rules. These rules to maintain what? That the rules. Okay, na? SQL server is provided some rules. That rules to maintain what's the integrity, data integrity. Data integrity means data quality. Data integrity means what? Data quality. To maintain the data quality, SQL server is provided some rules. They are called what? Integrity constraints. Understood or not? Then. So, like suppose here, to maintain the traffic, police department, then they introduce some traffic rules. Police department introduced some traffic rules to maintain. So then we have to satisfy that rule. If you satisfy that rule, then okay. If you don't satisfy the rule, then there will be a break. Okay, na? Then similarly, here also, like see, SQL server is given some rules. Okay, SQL server is given some rules. Like we use that rules. Okay, na? What for to maintain the data quality. So if you use that rules, quality is maintained, quality is guaranteed. If you don't use that rules, quality is not guaranteed. Okay, na? Data quality means if data is correct, quality is there. Data is incorrect, quality is not there. So to maintain the data quality, so SQL server is provided some rules. They are called what's that? Integrity constraints. Okay, then so no. So integrity constraints are the rules to maintain data what's that? Quality. To maintain data integrity. Data integrity means data quality. So they're used to prevent users from entering invalid data. Used to enforce rules. Used to enforce rules like minimum balance must be 1,000. I'm developing a database for bank. Okay, na? Every customer should open account with minimum of 1,000 rupees. He should open account with balance of 1,000. I want to declare that rule. How to declare this rule? By using what? Integrity constraints. So use it to enforce rules like minimum balance must be 1,000. Okay, then now understood now? What is the purpose? To maintain the to maintain data quality. Then if you use integrity constraints, quality is maintained. That means data will be always correct, valid. So it will not store invalid data. Next, to prevent users from entering what? Invalid data. So if you use this, users cannot enter invalid data. Always user enters what? Valid data. And using this, we can enforce rules like minimum balance must be 1000. Okay, then. So now, and what are the different integrity constraints in SQL Server? Okay, what are the different integrity constraints in SQL Server? The different integrity constraints in SQL Server, the different integrity constraints, in SQL Server. One is not null, next one unique, third one primary key, fourth one check, fifth one foreign key, sixth one default. So the different integrity constraints in SQL Server: not null, unique, primary key, check, foreign key, default. Okay, then. Oh. So not null, unique, primary key, check, foreign key, default. Then. So now, like we'll see one by one. Okay, now, but what are these? What are these? Integrity constraints. What is the purpose also, you know? What is the purpose of this integrity constraints? This one, this three. Next, so how to use them? You declare these constraints at the time of creating the table. You create table now, create table. At the time of creating the table, you declare these constraints. And these constraints can be declared in two ways. Okay, so these constraints can be declared in what's that? Two ways. There are two ways to declare these constraints. Then, so the constraints can be, integrity constraints can be declared in two ways. One method is column level, another method is table level. The constraints can be declared in two ways, column level and table level. Okay, then. So first we'll see column level, next we'll see table level. That time you'll understand what is the difference. Now, so then, now for example, one second, just see this. Then suppose, so I'm creating, just see this, create table, what's that? ABC, A integer, B integer, C integer, like this. I'm creating the table. Okay, na? Then, so here A declared as what? Primary key. What is primary key? Leave it at present. So if you declare the constraint like this type of declaration is called column level. If you declare like this type of declaration is called column level. Suppose I create the table, I declare the constraint like this: A integer, comma B integer, comma C integer, primary key A. And what this type of declaration is called? Table level. What this is called? Column level. And what this is called? Table level. So if you declare the constraint immediately, it is called column level. If you declare the constraint after declaring all columns, then it is called table level. If you declare immediately, then it is column level. If you declare the constraint after declaring all columns, then it is table level. First we'll see column level, later we'll see table level. Okay, then. So first column level. Okay, then. In maximum interviews, definitely they'll ask one question. What is primary key? What is the purpose of primary key? What is foreign key? What is the purpose of foreign? The remaining they may or may not ask, but compulsory you can expect this two. What is the two? Primary key and what's that foreign key? What is primary key? What is the purpose of primary key? Why we use primary keys? What is the foreign key? What is the purpose of foreign key? Okay, then column level. First, then if constraints are declared, immediately after declaring column, then it is called column level. If constraints are declared immediately after declaring column, then it is called column level. Okay. So if you declare the constraint immediately after declaring column, then it is column level. Now, so then, now what the syntax is? Create table name, next one, column name, next one, data type, size. Next here you declare what's the constraints. Here you declare the constraint like that, so on. So this is the syntax. Create table name, column name, data type, size, constraint like this. Okay, then. So let's take what's that? Let's take once again. We'll see once again. We'll see one by one. So your constraint is declared what? Constraint is declared what, sir? Immediately after declaring what column? Okay. Now let's see. What we'll see one by one. First we'll start with what? First we'll start with what, sir? Not null. Not null constraint. Sir, every constraint is a what? Rule. Constraints are what? Rules. Not null is a rule. Unique is a rule. Primary key is a rule. We have to follow that rule. Rules means someone should follow that rule. Traffic rules we have to follow. Yes or no? Like these are also rules. We have to follow that rule. Table data. We have to follow that rule. Data. You insert the data now. The data should follow that rule. If the data follow that rule, data is accepted. If data doesn't follow the rule, data is not accepted. Okay? Then. So what is the rule of not null? So not null constraint doesn't accept null values. Okay. Not null constraint doesn't accept null values. If any column is declared with not null, into that column, null values are not allowed. You know that now? Null, blank. So blanks are not allowed. Compulsory, you have to provide a value. If you don't provide the value, then what it gives? It gives what? Error. So any column declared with not null, into that column, value is compulsory. Value is mandatory. So that cannot be left with what? Blank. If it is left with blank, then it gives error. So then, now we can say a column declared with not null is called mandatory column. It's called what? Mandatory column. Mandatory means compulsory. Mandatory means what? Compulsory. Okay, then next. So, like 1 second. Suppose here okay, then let's see. Just I'm going to one website. Okay, then you see this here. If you see this here, all the fields are marked with what? All the fields are marked with what? Star. What is the meaning? Compulsory. These fields are mandatory. So if you leave this field with blank, then what this gives? This gives what's an error. Suppose I'm creating the account, then what this gives? This gives what's an error. Okay, na? So if this field left with what's a blank, then it gives what? Error. So value is compulsory. Same thing. What is this is? What is this is? This is front-end application. What this is? Front-end. Same thing I want to implement in database. Then same thing. Same thing I want to implement in database. Then not null. In front-end it is marked with star. In database it is declared with not null. Got it? In front-end it should be marked with what? Star. But in database it is declared with what, sir? Not null. Okay, na? Then. So in development, what they create first? What is created first? Will they create front-end form first or database table first? What they create? They create a front-end form or database table? Database table. First they create what's a database table. Next they create what's a front-end form. Yes or no? So because in database table, all these fields are declared with not null. Time in database table, all these fields are declared with what? Not null. While creating a front-end application, they are marked with what, sir? Star. Because that in backend, in database table, these fields are declared with not null. Okay? Then. So now let's take example. Let's take example. Create table. Create table. So EMP something. EMP 22, whatever. Employee number, integer. Employee name, varchar of 10. I want to declare that name is must. Name is mandatory. Person must have, employee must have what's her name. Name is mandatory. Then declare what's her not null. Declare not null. So create table EMP22, EMP integer, ename, varchar of 10, not null. This field is declared with what's it? Ename. Ename is declared with what? Not null. If ename is declared with not null, then what is this is? This is what's it? Mandatory. The field is mandatory. Okay. Then now what? Now insert the data. Now what's it? Insert data into EMP22. First create the table. So table is created. After creating the table, next I want to insert data into the table. Just check. I want to insert. What is insert into EMP22? Values employee ID is 100. I want to insert null. So let's try to insert null into ename. How to insert null? Type null. If you type null, null is inserted. Now let me run this command. What this command gives? Error. What it says, cannot insert null into what, sir? Ename. Cannot insert null into ename because ename is declared with what? Not null. So, but you are trying to insert null value. Okay. Then next, I'm inserting one more. Let's try to insert one more record. So 101, but I'm giving what's that? Something A. This is okay. This is accepted or not? Yes. Let me run this command. One row affected. But if you try to insert null, then it is giving error. That's all. So then I'm trying to insert null. Then what this command gives? Error. But if I try to insert 101, then A, then this will work. A. Okay, then. Okay, now next. That's all. This is what then. Next. That's all. Nothing more than this. What is not null is then. Nulls are not allowed. But the next one is what, sir? Unique. And what is unique constraint? So unique constraint doesn't accept what, sir? Duplicates. Not null doesn't accept nulls. Unique doesn't accept duplicates. So if any column is declared with unique, into that column duplicates are not allowed. Okay, then. If any column is declared with unique, into that column duplicates are not allowed. Now, example. So create table, like I'm creating a customer table. Customer ID integer, customer what's that name, what customer name, then varchar of 10, and customer what email ID, customer email ID varchar of some 20, 30. Next, what I'm see, the two customers should not be registered with same email ID. Two customers are not allowed to register with what? Same email ID. Then declare what? Unique. Okay, email ID varchar of 20. So into this email ID column, what is not allowed? Duplicates. You, Amazon, you want to register as a new customer. So then email ID, but you cannot give the existing email ID. If you try to give the email ID, then it says this email ID is already exist. Okay. Na? So then, so email ID should be what's her unique, should not be duplicate. So let me create this. Let me create this table. Table is what's her created, but it is saying table is already there. So drop table what customer. I'm dropping the customer table. Now create the table. Table is what's her created. Table is created. Next, after creating the table, next what? Insert. Insert into customer values. Customer ID is 100. Name is A. Customer ID is 100. Name is what, sir? A. Then email ID. What is the email ID? I'm giving some email ID abc@gmail.com. Okay, na? Then, so let me insert one row. Inserted. One row created. Next, I want to insert one more row. Insert into customer values. This is another customer, 101. 101 means another customer. Name is what, sir? B. And he is also trying to register with same email ID. He is also trying to register with what, sir? Same email ID. Then is SQL Server will accept? No. Let's try to run this. Then this gives what? Error. What it says? Violation of what, sir? Unique key constraint. Violation of unique key. Okay, now violating means you're violating the rule. Okay, now you're going against. Okay, now breaking the rule. Okay, then so because what the rule is, duplicates are not allowed, but you are trying to insert what? Duplicates. So that's why what this command gives. This command gives what, sir? Error. Okay, next. But suppose, can I insert null? 102. C. Can I insert null? Can I insert null? Null is allowed or not allowed? Null is allowed or not? One row affected. Null is allowed. Can I insert another null? 103. 103. Name is D null. Can I insert another null? Let's try to insert another null. Then that means you are trying to insert what's the duplicate. What this gives? Violation of unique key constraint. Because one null is already there, you are trying to insert what's it? Another null. So what this command gives? This command gives what's it? Error. This command also gives error. Okay, that's so what this gives? This gives what? Error. Okay then. Clear? Now. So unique constraint unique constraint doesn't accept what? Duplicates, but allows null values. unique constraint, sorry, doesn't accept duplicates, but allows what? One null. Only one null. Okay, na? Then that's this is unique, nothing more than this. Okay, because each one is a rule. Okay, na? I'm declaring that rule, I'm testing. So I'm inserting the data. At the time of inserting the data, what SQL server will what? Check. Okay, next. What is the next one? What is the next one is primary key. And what is the rule of primary key? Every constraint is a rule, na? What is the rule of primary key? Okay, na? Then so rule of primary key. Primary key what? Primary key doesn't accept what? Duplicates and nulls. So primary key doesn't accept duplicates and nulls. So this is the rule. Not null doesn't accept nulls. Unique doesn't accept duplicates. Primary key doesn't accept duplicates and nulls. Now we can say primary key is the combination of unique and not null. Yes or no? So primary key is the combination of what, sir? Unique plus not null. Primary key is the combination of unique and not null. So primary key is the combination of unique and not null. Okay, now let's see. Okay, now suppose, for example, just listen. Suppose here I designed a table for bank customers. For storing the customers' data, I designed a table like this. I'm storing what? Name, next one, address, next one, what's her? Balance. I'm storing like this. Only name, address, balance. I designed a table like this. Now, so like if I store like this, what is the problem is? If I store the data like this, what is the problem is? The problem is, so uniquely identifying customers is difficult. What the problem is? Uniquely identifying customers is what's the difficult? Because there may be number of customers with what? Same name. Number of customers with what? Same address, same balance. Then problem is uniquely identifying customers is difficult. I'll go to the bank. I'll ask, sir, what is my balance? Then they'll ask, what is your name? What is your name? I give the name. Okay, na? I'll give the name. Then my name is Vijay. Then they will go to customer table, find out the customer with name Vijay. They can find number of customers with name Vijay or not. Yes. They'll ask my address. I give my address. Again, they can find number of customer with same address house. So the problem is uniquely identifying customers is what's difficult. That is the reason every bank introduced one. What is that is called? Account number, customer ID like that. So they introduced one account number. What for this? Uniquely identifying. If one account number is given to one customer, the same account number is not given to another customer. Okay. Then they want to use this account number to uniquely identify. But they cannot use this name, address, balance. Now that's why they introduced what's the account number. They want to use account number to uniquely identify. So if they want to use this account number to uniquely identify, into this account number, duplicates and nulls are not allowed. So then declare account number with what's the primary key. Understood or not? That means remember, in table, one column must be there to uniquely identify. That column must be declared with what's the primary key. Understood? Every organization stores what? Every organization stores what, sir? Employees data. Every organization stores what? Employees data. Employee ID, employee name, employee what, sir? Salary. Employee ID, name, salary. Okay. Then now, sorry, I'm storing the data like this: name, salary, job. If you store like this, what the problem is? Uniquely identifying employees is what? Difficult. Okay, there may be number of employees with same name, same salary, same jobs. That is the reason every organization introduced one, what that is called EMP-ID. What for? To uniquely identify the employees. So if they want to use employee ID to uniquely identify into this EMP-ID, duplicates and nulls are not allowed. So then declare this EMP-ID with what, sir? Primary. Understood and not? Then. So here, what the purpose is, okay, na? Then. So in tables, in database tables, one column must be there to uniquely identify. That column must be declared with what, sir? Primary key. Okay, na? Then in database tables, one column must be there to uniquely identify the records, and that column must be declared with what? That column must be declared with what, sir? Primary. Okay, then. So purpose of primary key to uniquely identify. Okay, then. Oh, next. Then now let's take example. Take what's an example? Create table EMP33. The field is EMP ID, integer what's the primary key. E-name what? Varchar of 10. Not null. Okay, na? Then enough, na? Otherwise, if you want, you can take salary also. Sal name. Okay, na? Money type. So I'm taking just three fields. Employee ID declared with what? Primary key. So when this is declared with primary key, into this duplicates and nulls are not allowed. So then using this EMP ID, we can uniquely identify the employees or not. Yes. Using EMP ID, we can uniquely identify because it is not allowing the duplicates and null values. Understood? Then. So create the table. Okay, create the table. So table is created. And after creating the table, I want to test. How to test? To test what? Insert. Insert into what? EMP33 values, ID is 100, name is A, salary is what? 5,000. This is inserted or not? Yes. Let me run this. One row affected. This is inserted. Next one. I want to insert one more record. I want to insert one more. 100. Again, I am trying to give the same value. 100. Name is what, sir? B. Salary is what? 4,000. So I am trying to insert. Then what this gives? This gives what, sir? Error. Violation of primary key constraint. This gives error. Violation of primary key constraint. Okay, now next one. What the next one is? Suppose then next one. Insert into EMP33. I'm trying to insert what's the null value. For employee ID, I'm trying to insert null value. So let's try. Let's execute this command. What this command gives? Error. Cannot insert null into EMP ID because EMP ID is declared with what? Primary key. Primary key doesn't allow null values. Okay, na? So it doesn't allow duplicates and nulls. So using this column, we can uniquely identify or not? Yes. No. So this command gives, okay, this command gives what's it? Error. This command also gives error. Next, because what? Okay, then. So like because EMP ID doesn't allow duplicates and nulls. So using EMP ID, we can what? Uniquely identify the records. Uniquely identify the employees. Okay, then. Okay, now then plus here and only one primary key is allowed per table. Only what, sir? Only one primary key is allowed per table. In table we cannot have multiple primary keys. So if we declare multiple primary keys, then it gives what, sir? Error. Like 1 second, just see. Suppose here, then 1 second, just try to create this. Then so I'm declaring A as primary key plus what, sir? B as primary key. I'm declaring two primary keys. Then what this gives? This gives what? Error. What it says? Cannot add multiple primary key consigned to table what? ABC. So how many primary keys are allowed? Only one. Okay, na? Then. So now next, let's see here. Then what that point is? A table allows, once again, only one primary key is allowed per table, and table cannot have multiple primary keys. In table we can have multiple columns can be declared with unique. Yes. Multiple columns can be declared with not null. Yes. Multiple columns can be declared with check, foreign key, default. But only one column can be declared with what? Primary key. Understood or not? Then. So we cannot declare multiple primary keys. But suppose sometimes, 1 second, just see. I'm creating a table for what's the customer. Listen first. Customer table. Banks, for every customer, they give what? Customer ID. Customer ID integer. And this customer ID is what's the primary key. Because one ID is given to one customer, the same ID is not given to another customer. Customer, what's the name? Varchar of 10. This is what? Not null. And they want to store customer what's the Aadhaar number. So bank wants to store customer Aadhaar number. Aadhaar number is what's the numeric? How many digits? 12 digits. What is the rule for Aadhaar number? What is the rule for Aadhaar number? two customer Aadhaar number should not be same, and Aadhaar number should not be blank. Yes or no? Aadhaar is must or not? Yes. And then what? So can we declare primary key? No, because you already declared primary key for customer ID. You cannot declare primary key for Aadhaar number. Yes or no? Because table allows how many primary keys? Only one primary. Then how to handle this case? So then what you have to do is declare what, sir? Unique not null. Declare what? Unique not null. So when you declare unique, duplicates are not allowed. If you declare not null, nulls are not allowed. Next one, bank wants to store what? PAN number. So what is this is char of 10 because it is alphanumeric. Okay, na? Char of 10. Then what is the rule for PAN number? Same. Two customer PAN number should not be same and PAN number should not be null. Then declare what? Unique, not null. Like, listen. So what is the point here? Only one primary key is allowed per what, sir? Table. So if we want multiple primary keys, then if you want what, sir? Multiple primary keys, then declare one column with what? Declare one column with primary key and other columns with what? Other columns with unique, not null. Unique and not null. So this is the example. Okay. Then okay, na? That's so we'll continue this tomorrow.